Good afternoon. We were discussing different disk scheduling algorithms, and we have seen two algorithms in which the first one there is first come first serve and SSTF, shortest seek time first. So with respect to FCFS, as we need in the beginning, we supposed to have the head pointer where it is exactly the value of head pointer where it points to right now, and then the queue list of the queue values scheduling. So now with respect to that, we'll go through with the FCFS, first come first serve. With respect to first come first serve, head will start based on the appearance of the queue values. With respect to this example, the initial value is 98, then 193 and 37 and so on. So the reading or scheduling will start from 53 because it is already in 53 now. From that particular point, the scheduling takes place as first come first serve, that is in the form of queue, first in first out. So according to that, if this entire set if we treat it as an array or index, so with the index 98 with 0, 183 with 1, 37 with 2, 3 and so on. So 98 is served first. So from 53, 98 is served. From 98, the next one is 183, moves to 183, then 37, come back to 37 and so on. This is first come first serve. And after that we have seen shortest seek time first. As usual, we know the header where it is pointing now. Header pointer is 53. So out of this entire queue of the set, is supposed to find out next immediate or shortest point. So from 53, out of these 65 is the nearest one. So to move from 53 to 65, it needs very less time. That's why it will select 65 and addresses 65. From 65, it moves to 67 because from 65th point, 67 is nearest. That's why it serves 67. From 67, the remaining out of this remaining point, 37 is nearest one. That's why 37 is visited. From 37, 14 is visited. Out of these, no other less value is available over here. That's why 14 is served. From 14, out of these, 98 is the shortest time. So that's why 98 is served, 122, 124 and so on. That is shortest seek time first. So these two algorithms we have seen in the last class. Today we'll cover other algorithms. The next algorithm is scan algorithm. This scan algorithm, sometimes it is also called as elevator algorithm or staircase algorithm also. Elevator or staircase. Because in this case, the disk arm starts from the header as usual. So based on the last point, whether it is if it reached that particular point from the other end or from the left hand side. So if you consider left and right, whether the disk is come back to from left side or from the right side, we'll go through with the example so that you can easily understand. So in general, the disk arm starts from the one end, it moves towards the other end, and while performing that, it will serve all the requests from left to right. And once it reaches the end point, it will turn reverse, and again in the reverse direction, it will serve all the requests. For example, if you consider the staircase or elevator algorithm, consider elevator algorithm. Say in malls and all, we use elevators to move from one floor to another floor. So in that case, what we do, say consider the Mangalore city center, we'll move, go to ground floor. Then we'll use the elevator. We'll move to first floor. We'll do window shopping in all the first floors. Then move to second floor. We'll do window shopping in second floor. Then move to third floor. We'll do window shopping in third floor, and so on. Right. So now what happens? How this works? So we visited floor by floor as based on elevator, and then in that each floor we'll visit all those shops as window shopping. Same situation applies in this scan algorithm also. So based on the starting point, so if we start from one particular point, we'll move on the other end by visiting all the shops or all the requests. Similarly, while returning, we'll do the reverse case. This is how scan algorithm works. So we'll take an example. Here we have a same example, queue with some set of request values and header value. Header value starts from 53. So now in the previous example, previous situations before the head reaches 53, it came from the other end, from right hand side. So by considering that into factor, now head should move to the left hand side. So that's why from 53 it starts to move towards left. So while moving left, we supposed to find out which are the requests we have in this particular queue. Nothing but we supposed to trace out which are the values which is less than 53. So that is visited now. And why are doing all that? Why are doing that particular survey? That is while moving from header pointer towards left. So we will visit all those request points. We'll give a priority to those requests. So out of this particular queue, less than 53, we have 37, we have 14, right? So these two are available in this list. So from 53, 37 is served. From 33, 37, 14 is served. So after that, where should it go? It won't move to the next point. It will come back to the original initial position, that is 0, initial point. From the initial point, it will take a U-turn. It will take a U-turn and it will move towards other end. So while moving towards other end, it will serve all those requests. So from this particular point 0, so the remaining is 65, then 67, then 98, then 122, 124, and so on. So it will reaches the right hand side, other end. Again, from this particular point 199, it will take a U-turn. If there is any other set of values, it is appeared, then visiting all those places. That is how scan algorithm or elevator algorithm or staircase algorithm works. Got it? Any clarification? So we'll start from header, that is 53. We'll move towards left. So while moving left, we'll visit all those points 37 and 14 according to the queue. Then we'll take a U-turn in initial point, that is 0, and we'll start moving to the right hand side or other end. While moving to the other end, we'll serve all those places which comes from the list, in the list. So how to visit? Again from ascending order. So you may recreate this particular algorithm like this way. From 53, always we supposed to move from 53 towards left. So you can rearrange all this queue in descending order. So just note down 53 to 0, which are the locations we supposed to visit, and visit all those. Then take U-turn, then restructure the queue. So from ascending order, visit all those points till the end. That is how scan algorithm works. And little bit fine tune with the scan algorithm, we have C scan. In this C scan, the head moves from one end of the disk to the other. So while moving from one end to another end, it will serve all those requests. So now the difference is, whenever it reaches the other end, it immediately returns to the beginning of the disk without servicing any requests on the return tape. So it will do only one way trip. So why this is C scan is important is, When you wanted to perform only read operation from the disk, only read operation, then we may go with C-scan. Why? Because all those disks are in circular fashion. Disks will have n number of platters, nothing but circular plates with the magnetic coating. So we'll have n number of those kind of cylinders based on the manufacturer. However, each cylinder will have number of tracks. Each track is divided into sectors. That is how it works. So now in this C-scan, it will serve from one end to other end. So while performing that particular situation, that particular scheduling, so it will serve all those. Nothing but it will start from the beginning and move towards other end, and while moving it will serve all those. When it reaches the other end, it will just return it in empty hand and come back to initial stage. So always starts from initial point only. We'll see the example. So here head starts from 53. So 53, from 53 is supposed to start it's a scheduling direction towards other end. So now because 53 is already in between, so no need to go back to previous step. We are assuming that to reach 53 it already started from 0. So that's why we started from 53. We'll move on towards the other end, right hand side. From 53 we'll reach 65, 65 to 67, 98, 122, 124 and so on. Now when it reaches other end, it will just return back without serving any one, request. Again come back to 0 initial position. From there it's supposed to begin 14 and 37. So it will stop over here 37. So now what happens is, if any other request will appear in this case, say after 37, say it encountered 150, just move to 150. And after serving 150, consider it may appear 20. So what to do now? It will just reach the other end over here, return back without serving 20 here, just to move back to initial position 0, then again start to serve to 20. That is how it works. That is a C-scan. Difference between previous scan and C-scan is, with respect to scan, it is an elevator kind of thing or staircase. With respect to this, from 53, first it should move from the beginning. That's why while coming back to the left hand side, it will serve all those. Then take U-turn, move towards other end. While moving either reverse or forward direction, it will serve all those requests which comes in line. That is a scan. With respect to C-scan, so the head starts from its own position and move towards other end. If head is in between the line, in between the array, say 53 over here, it should move towards 199. So it will serve all those and stop it at 199, take a U-turn, again come back to the initial position, that is 0, and from 0 onwards it should start serving all the requests. That is how C-scan works. Any doubt, any clarification, you can raise your hand. So no doubt, no clarification, we are moving further. Next one we have C-look. This is a look version or nothing but a combination of scan and C-scan, combi of both. So now what happens is, over here is, here the arm or the request or the header moves to the last request in each direction and then reverses the direction or take a U-turn immediately without first going all the way to the end of the disk. This is over here. If you take the same example, based on the request value, based on the request, it will move towards the other end by serving all those and coming back to the next value, minimum value, without going to the end point. That is only the difference. It won't go to the end point. So now with respect to C loop, from 53 we are starting serving all the requests 53 to 65, 67. Now it is in forward direction, left to right, 53 to. So according to the example over here, Q values, we have 183, that is the largest value. So it will reach 183, serve it and take U-turn. So according to the previous algorithm, it won't visit any of the resource, any of the requests. It won't serve any of the requests while returning. It will just return back, and while after returning, which is left, only 14 is left, 14 and 37 is left. So it will take U-turn in 14. After serving 14, it will take U-turn, and the remaining is 37, that is served. Now, if you consider two more example to add two more requests into this, consider 150. After 37, 150. So 150 is served. After the take U-turn and wait. So if any value appeared, say 20, then it will take U-turn and come back to 20. So we already took U-turn in 20. So if there is any value higher than 20, it is served. If it is less than any value of 20, then it is served. So only difference between the previous cscan and clook is, with respect to clook, it won't visit endpoint. There is only difference between the previous scan and look. So any doubts so far? Please raise or please ask any doubts if you have. It's very easy. So you may expect some problems, the exams based on this. You're supposed to solve. However, I'll share some of the, I'll pose some of the questions that is to be solved via using this disk scheduling algorithms. So now we'll just brief along with our which one to select for our own disk scheduling. So over here, with respect to in general, so SSTF is common. That is shortest time first, shortest seeking time first. That is in general we may face, we may use in general day-to-day life. So that is common and natural. Scan and ski scan. So what will be the hectic part in this is, we need one more support to look after the endpoint, because it should take U-turn after serving C-scan. And one more load is or empty load, or we use the particular resource or our header as an empty vehicle, because while returning it won't serve anything, it will be empty. So that is one of the thing. So now why or where this is applicable is scan and C-scan is, if your hard disk is full, then it is very easy, because you start from one end to other end, so that all files are searched, all tracks are searched. So now based on these three algorithms, again performance, how we can measure performance, we have seen the formula on the other day. So that is the number of requests and type of requests, based on that performance is decided. So type of request is either read or write or alter or modify. Alter modification may include delete also. Based on that, the performance varies. So now while providing or while asking for a different request from the disk or disk servicing request, based on the file allocation method also. So file allocation in the sense, the different file allocation method we know very much familiar with, whether it is a one-time usage or whether it is a permanent or different allocation mechanisms that we use. So while deciding that one, we need some more partition to have our metadata value. So who is the user, when is used, type of user, and whether it is admin or normal user, privileged user, all those kind of things. So based on that, again the disk service may vary. And then coming to the disk scheduling algorithm. So we can change the algorithm based on the usage or based on our priority, or whenever it is necessary. You can replace it with anything, or you can write a new scheduling algorithms on your own. So by default, we have either SSTF or look algorithm. So look algorithm is the previous one. We'll move from left to right without touching the endpoint, and we won't serve anything while returning. So we'll serve only in forward direction only. That is look. SSTF, shortest seek time first. So now the main headache on this controller is controlling the rotation, the spindle rotation, because it's supposed to look after all those. Consider we have shortest time first algorithm we implemented. Say you wanted to save some file in a disk. Consider there are 10 number of platters in your hard disk. So out of this 10 number, we don't know where exactly the file is available. So you wanted to read a particular file from the disk. So if you implement SSTF, say consider you're supposed to open 10 files simultaneously, you give a queue. So now based on SSTF, it will look after all those file location by the lookup table which is available in disk setup, and based on that it is served. So now to maintain that rotation, our disk controller should be given with continuous power supply, and there should be no delay in between. So if there is any delay or delay in executing this look, or delay in reading or writing a particular file, then there will be a rotational latency. So how it is calculated, it is very difficult based on your machine. So we can't say it is exactly to the same value can be available for different machines. Different machines give different value. Different hardware structure will give different value for this one. Delay will be more if you are using old machine with the USB 2.0 or 1.0, or very slow system which is having processor very less clock speed, Pentium 3, Pentium 4, all those kind of thing, single core. So this will be there will be a little bit delay. So any doubt so far? Okay, just we'll cover this disk management, then we will discuss any clarification or doubts. So we have two types of formatting here, low level formatting and physical formatting. Coming to disk management part. So disk management is nothing but before installing your OS or during the installation of OS, we will decide how many number partition we need, and based on that we will format the disk. Or you are very much familiar with pen drive concept. So pen drive, whenever you put pen drive into your machine, you may want to format it. So again, it will give you two types of formatting if you visit the clearly. Quick format and low level format. Right. So this low level and physical format, these two different kind of thing. So now based on that particular formatting is nothing but we are managing our disk. We are ensuring the disk works as along with our OS operating system, because based on the operating system that we use, based on that the disk is formatted. So now based on the operating system, the sectors or tracks are decided. Each sector or each data can be read in a single shot, and the metadata value is also stored in that particular pen drive. That metadata form will have username, user credentials, date, time, when you formatted, all those things, and then error CC, error correction codes, CRC, all those things. In general, 512 bytes are reserved for that particular. This is minimum. 512 bytes are very minimum with respect if you are making use of DOS. If it is DOS, your pen drive will make use of 512 bytes, that is not usable for you. That 512 bytes will contain all this metadata information in that. That is how we manage with the disk. So whenever you format, this particular 512 bytes are rewritten in time. And again, it can be usable if you want for a usage of OS, that is OS priority. Then we have you can have the files, or you can hold the files in different partitions to make different groups of selectors, like how we partition, or from you can merge two different partitions using some tools, or if you are very much familiar with the Unix commands, then you can merge all those, you can partition again, you can make some blocks, you can make some clusters, you can make some particular drive is usable only for a particular user by locking it, all those. So now with respect to this disk management, only thing we supposed to remember, one is the formatting level, low level and physical formatting, and why it is used, how it is used. And then logical formatting, that is making a file system. That is logical formatting in general is done based on the user perspective. So after initial partitioning, we may go with logical formatting. Logical formatting is nothing but you are creating a directory. You may make use of mkdir, or if it is Windows system, you can click on your drive, open a drive, right click on that, create a new folder, rename it, and so on. That is how logical formatting. You are creating a file system based on your operating system. Then we have something called boot block or bootstrap loader, where the ROM is located. Sorry, bootstrap is located in a ROM. So we load the initial program, where the program will have entire path where exactly operating system is stored. For example, if your machine has two operating system, consider Windows and Linux, bootstrap loader will load all those, whatever the operating system you have in your machine, both the options should be made available to the user. So that is the job of bootstrap loader. Any doubt? So how it works? You can see in the diagram. Consider we have Windows 2000 in our machine. We're supposed to boot from that. So what to do with that? We have initially 4 partitions. MBR, we made a separate partition where that boot code and partition table is loaded. What this MBR will have? It will have the path to the operating system. Nothing but, say you are trying to have operating system installed in partition 3, then the path from this to this particular partition 3 should be available in this partition table. Then say consider you are trying to have, along with Windows, you are trying to have Unix also. You may try to load that Unix in partition 2, then in the partition table that's also maintained. So initially, whenever you switch on your machine, this MBR is loaded with the boot code by giving option of select 1 or 2. Select 1 with the Linux, select 2 with the Windows. That is how it works. So any doubt or any clarification, if you have, you may ask. Any doubt, any clarification? If there is no doubt, I guess it is enough for the day, or shall we continue?
Enough, sir. Enough, sir.
Okay, okay. Nothing to worry. We'll stop it here. I'll discuss in tomorrow's class. So if you have any doubt, please you can ask. And please submit your assignment on time. And
Tomorrow Sunday, no.
Sunday, for everyone will have Sunday only. You are already in home.
So don't do.
So it is Sunday for you. Every day is Sunday for you. And on the other day,
No, sir. No, sir.
Gokul was asking for linking holiday, you know. Yesterday it was Good Friday, today it was Saturday, and next we have Sunday, so we may get a linking holiday. Right. Okay. Take care, everyone. Stay safe, stay home. Okay. If you have any
Yes, sir.
clarification doubt, you can ping me. Thank you.
Thank you,
Thank
sir.
you, sir.